You know, uh, trying to stay ahead in any field, especially a complex one. Oh, it can feel kind of overwhelming sometimes, right?
Yeah, for sure.
Like in heavy manufacturing, just keeping all those intricate machines running smoothly, you're constantly absorbing tons of information, just trying to make sure everything operates at peak performance. And that's really the whole point of these deep dives we do,
Right.
to kind of cut through the noise and give you a clear understanding of what truly matters and do it quickly.
Yeah, think of it like a targeted briefing,
Exactly.
like extracting that essential knowledge so you can really grasp those core advancements without getting bogged down in all the technical details.
And then today we're diving into a pretty significant area,
Yeah.
how to make equipment more reliable in heavy manufacturing.
Mm-hmm.
And we're not just, theorizing here. We've got a fascinating real-world example we're going to
Right.
dissect. It's a detailed case study from Cognitive Market Research. It's a recent one, too, just came out in March of this year. The title is Enhancing Equipment Reliability in Heavy Manufacturing, CMR.
All right.
So our mission today is pretty clear-cut. We're going to break down exactly how this leading company tackled the age-old problem of unexpected equipment breakdowns, and they did it by embracing some really cutting-edge technologies,
Yeah.
specifically the power of AI and machine learning. Right,
Interesting.
and trace their journey, how they went from just reacting to these failures to actually predicting them before they happened.
Hmm.
And we'll pinpoint the key strategies they used along the way and the really impressive results they achieved.
Sounds good. Let's do it.
All right, so um, the case study kicks off by laying out the main problem this heavy manufacturing company was facing. And it wasn't just some minor annoyance, was it?
No, not
They were dealing with constant, unforeseen equipment failures.
right. Imagine
Yeah.
in a heavy manufacturing plant,
Oh, yeah.
production lines grinding to a halt,
Uh,
the meters running on these costly emergency repairs, and it just creates this cascade of operational snags.
yeah.
And the impact wasn't just contained within their own facilities either.
No.
These disruptions were actually causing problems throughout their entire supply chain.
It sounds like the maintenance practices they had in place just weren't cutting it.
Right.
The study mentions the traditional preventative maintenance, it kind of fell short. What were the limitations they were running into with that?
Well, the traditional approach, it often faces this sort of dilemma. You either stick to a really strict calendar-based system
Yeah.
and you end up servicing equipment that might be perfectly fine.
Right.
And that's obviously a waste of resources, and sometimes it can even introduce new problems by intervening unnecessarily.
Yeah, you're almost better off leaving it alone.
Exactly. Or on the flip side, you don't service frequently enough, and then you run the risk of premature failures.
Right.
So it's often this balancing act based on averages,
Yeah.
rather than the actual needs of the equipment. And then of course there's the reactive approach,
Right.
waiting for something to actually break down before you rush to fix it. And that's obviously the most disruptive and expensive scenario of all.
The worst of both worlds.
Yeah, exactly.
So their solution was to move towards something a little more intelligent,
Mm-hmm.
a system that could, think ahead, a predictive approach.
Right. They made the strategic decision to really harness the power of AI and machine learning to develop a whole new predictive maintenance system.
Okay.
The fundamental goal was to shift away from that time-based reactive model to one that was driven by the actual condition of the equipment, the data it was generating.
That makes a lot of sense. Instead of just assuming something needs attention after a certain number of hours, you're constantly monitoring its
Yeah.
health.
Exactly.
So what were they hoping to gain from this shift? What were the projected benefits?
Well, enhanced equipment reliability was obviously paramount, right?
Yeah.
Fewer disruptions, more consistent output.
Right.
But beyond that, they were also aiming for some pretty significant reductions in their maintenance expenditures.
Okay.
They wanted to extend the operational life of these very expensive assets.
Sure.
And ultimately, boost the overall efficiency of the entire plant.
So it was a bold undertaking,
Yeah,
but with the potential for some really big rewards if they could pull it off.
absolutely.
The case study, it uses the term comprehensive approach.
Hmm.
What exactly did that involve?
Well, it wasn't simply a matter of just, throwing some AI at the problem and hoping for the best.
Yeah.
Their strategy involved several key layers all working together. First, they had to establish a really robust system for data collection.
Oh.
Then they needed to develop sophisticated algorithms to analyze all that data.
Mhm.
And then they implemented real-time analytics to identify potential problems as they emerged.
Right.
And finally, and this was crucial, they integrated this whole system with their existing ERP systems
Okay. Yeah.
to make sure it was woven into the fabric of their operation.
So it became part of their everyday workflow.
Exactly.
Okay. So let's dig into the how-to here. You mentioned data collection. That's obviously the foundation of the whole thing. So how did they actually go about gathering the data they needed?
So they deployed a really extensive network of IoT sensors
Okay.
across all their critical machinery, and I mean everything from the main production lines to individual motors, hydraulic systems, even the conveyor belts that moved materials around. These sensors basically became the digital senses of the entire operation.
So what kinds of information were these digital senses picking up?
Oh, all sorts of vital signs, vibration patterns,
Okay.
which can be, a telltale sign of imbalance or wear and tear, temperature fluctuations, which might indicate overheating,
Right.
variations in pressure within hydraulic systems, even the levels of energy consumption, which can sometimes reveal if a machine is working harder than it should be.
Okay.
And in certain applications, they were even monitoring things like the viscosity of fluids.
So you've got all this data pouring in from all these different points. Where did it all go?
It was all transmitted to a centralized platform in the cloud.
Okay.
The central hub essentially allowed them to aggregate and analyze the massive amount of data coming in from all those sensors, point wide.
So it wasn't just about the real-time data, though, was it?
No.
They also incorporated historical information into the mix.
That's right. To really refine the accuracy of their predictions, they integrated their historical maintenance records into the system.
Interesting.
So by combining that real-time operational data with the historical context, previous failures, maintenance logs detailing repairs, servicing, things like that, the AI models could start to see those more subtle patterns
Okay.
and potential failure precursors that might not be obvious from just the real-time sensor readings alone.
It's like having a long-term memory.
Exactly.
So you have this constant stream of data feeding into the system,
Mm-hmm.
and that's where the machine learning kicks in. How did they go about developing these predictive models?
Well, they used a combination of supervised and unsupervised learning methodologies.
Okay.
So think of supervised learning as like showing an AI model a ton of examples,
Right.
Healthy equipment operation, instances of equipment failure,
Yeah.
and you label each one really clearly. And by learning from these labeled examples, the AI can then identify similar patterns in new unseen data
Okay.
and predict whether a failure is likely to happen.
So they used all that historical failure data to train the model to recognize a breakdown before it happened.
Exactly.
So what about unsupervised learning? What role did that play?
So unsupervised learning is a little different.
Okay.
Instead of, being explicitly shown examples of failures, the AI is kind of left to its own devices
Right.
to explore the data and look for anomalies or unusual patterns
Mm-hmm.
without any prior knowledge of what a failure actually looks like.
So it's more about spotting the unexpected.
Yeah, that's right. This is particularly useful for identifying new or unexpected types of problems that haven't been seen before. It's almost like the AI is saying, hey, this data point looks really different from everything else. We should probably take a closer look at this.
Yeah.
Even if it hasn't been explicitly told that this specific deviation is a sign of trouble.
Right. It's kind of like an early warning system for the unknown.
Exactly.
And these models, they weren't just static, were they?
No, not at all.
They continuously evolved over time.
Yeah, the models were designed to continuously learn and adapt as new data became available.
Right.
So every new sensor reading, every maintenance intervention, all of it provided additional information that helped to refine the models and enhance their predictive accuracy over time.
So it's like this ongoing cycle of learning and refinement.
Precisely.
The case study also mentions the use of deep learning techniques, specifically CNNs and RNNs.
Mm-hmm.
Can you break down what those are and why they were so important in this context?
Yeah, so deep learning with architectures like convolutional neural networks, those are CNNs, and recurrent neural networks, RNNs, they're really good at processing very large and complex data sets, in a big, sprawling manufacturing facility, you might have thousands of sensors generating data constantly. So that the sheer volume of information is enormous.
Right.
CNNs are particularly good at recognizing patterns in data that has spatial dependencies, like those subtle variations in vibration signals picked up by the sensors.
Okay.
It's almost like how image recognition software identifies shapes and textures.
Okay.
RNNs, on the other hand, are designed to understand sequences of data over time,
Mm-hmm.
which is crucial for analyzing trends in sensor readings and predicting future behavior based on historical patterns.
Right. So they're looking at the past to predict the future.
Exactly. Ultimately, these deep learning techniques allow the system to uncover hidden correlations within that complex data
Right.
and generate more accurate forecasts with a lower rate of false alarm.
Which is really important
Yeah,
because you don't want this system crying wolf all the time.
exactly. You don't want the maintenance crews to start ignoring the alerts because there are too many false positives.
Right. Right. So the system's gathering data. The AI is analyzing it, learning from it. What's the next step? How does this actually translate into preventing those equipment failures?
So that's where the real-time predictive analytics and the alert system come in. So the AI is constantly scrutinizing that incoming sensor data, looking for any deviations from normal operating parameters.
Mm-hmm.
And when it detects an anomaly that crosses a certain threshold, it automatically generates alerts.
And those alerts, they're not just generic warnings, are they? How are they communicated to the maintenance teams?
They're designed to be really timely and actionable.
Okay.
The system can send out notifications through several different channels, intuitive dashboards that the teams can monitor,
Uh-huh.
email alerts for issues that might need attention but aren't immediately critical,
Right.
and even mobile apps for on-the-go notifications.
Wow.
So the right information gets to the right people no matter where they are.
So instead of finding a catastrophic failure after it's already happened, they're getting an early warning,
Exactly.
which allows them to take steps to prevent it.
Right. And this proactive approach allows them to schedule maintenance at the most convenient times,
Mm-hmm.
ideally before a minor issue turns into a major breakdown.
Right, right.
So you're significantly reducing the chances of those sudden disruptions
Right.
and the high cost of emergency repair.
Yeah, you can plan the downtime, order the parts you need in advance, make sure you have the right people available.
Exactly.
So it can really optimize that whole maintenance workflow.
Yeah.
And it sounds like the system can do more than just issue alerts, right?
Right.
The case study mentions automated decision-making.
Yeah, so the integration with their ERP and CMMS systems
Yeah.
is where the real workflow optimization happens.
Okay, remind me what those are again.
So ERP, that's Enterprise Resource Planning.
It's the software they use to manage all those core business processes, like inventory and resource allocation.
Okay.
And then CMMS, that's Computerized Maintenance Management System.
Okay.
That's their digital system for tracking and managing all their maintenance activities.
Got it.
So based on the AI's predictive insights, the system can actually recommend very specific actions,
Okay.
like when to service a particular component.
Mhm.
It can automatically start the process of ordering replacement parts, even schedule the right maintenance personnel with the skills needed for the job.
Wow, so it's not just saying, hey, there might be a problem.
Yeah.
It's actually helping them solve it.
Exactly.
That's really impressive.
And this predictive intelligence enables a real shift away from those rigid time-based maintenance schedules
Right.
towards those dynamic condition-based plans.
Okay.
So instead of servicing a machine just because the calendar says so, even if it's running perfectly fine, they can focus their efforts on the equipment that actually needs attention
Right.
based on its condition and predicted future state.
So you're preventing unnecessary maintenance
Exactly.
and making sure that any machine that's showing signs of potential failure gets the attention it needs.
Right.
And like any good system, this isn't just a one-time fix, is it?
No.
There's a feedback loop built in for continuous improvement.
Absolutely. The system has a self-learning feedback loop,
Okay.
and the maintenance personnel on the ground, they play a huge role in that.
Mm-hmm.
They provide feedback on how accurate and effective the AI's recommendations are.
Okay.
Were the alerts timely? Did the suggested actions actually fix the problem?
Right.
All that real-world data, along with the expertise of the maintenance teams, gets fed back into the AI models.
So the system is constantly learning and getting better.
Exactly. So over time, the models adapt to new conditions.
Uh-huh.
They learn from any new failure patterns that might pop up. They
Yeah.
incorporate new best practices. So this iterative learning process ensures that the predictive capabilities are always improving, making it more and more accurate and reliable with each maintenance cycle.
So with all this data processing and these sophisticated models, how did they make sure the predictions were actually reliable? Data validation seems like a pretty critical part of this.
It's absolutely crucial. They used several strategies to ensure the accuracy and reliability of the predictions. One really important method was correlation analysis.
Okay.
So they basically cross-referenced the predictive forecasts from the AI with their historical failure records.
Right.
This allowed them to fine-tune the model, minimize both false positives, where a failure is predicted but doesn't happen,
Yeah.
and false negatives, where a failure occurs without any warning.
Right, right. You want to avoid both of those.
Yeah.
So they're comparing the model's predictions against what actually happened in the past.
Mm-hmm.
And they also did some real-world testing, didn't they?
Yeah, they started with a pilot phase. Okay. Instead of rolling out the system across the entire plant all at once, they chose a subset of their equipment for the initial deployment.
Okay.
This allowed them to closely monitor its performance and gather detailed data in a controlled environment.
So what were they looking at during this pilot phase? What metrics were they using to judge how well it was working?
They focused on some key performance indicators,
Okay.
KPIs, things like mean time between failures, MTBF,
Okay.
which measures the average time between breakdowns.
Right.
They also looked at mean time to repair, MTTR,
Mm-hmm.
which tells you how long it takes to get a piece of equipment back up and running after a failure.
Okay.
And very importantly, they tracked the actual cost savings in maintenance operations over a 6-month period after the pilot.
So were the results of this initial testing promising?
They were really encouraging. The case study highlights a significant reduction in unexpected breakdowns
Mm-hmm.
on the equipment that was included in the pilot. So that early success gave them a lot of confidence in the potential of predictive analytics to really transform their maintenance strategies.
That's great. And they also took into account the feedback from the people who'd be using the system every day,
Oh yeah,
the
absolutely.
maintenance engineers and technicians.
They actively sought feedback from the folks on the ground who were actually using those AI-generated alerts and recommendations.
Mm-hmm.
They wanted to know if the information was clear and easy to understand,
Right.
if the suggested actions were practical,
Mm-hmm.
and if the system was actually helping them make better decisions.
And why was this qualitative feedback so important?
Incorporating that frontline feedback was crucial for a couple of reasons.
Okay.
First, it ensured that the system was really aligned with the real-world needs of the plant.
Right.
And second, it helped with user acceptance.
Uh-huh.
If the people who are actually responsible for maintenance find the system useful and intuitive, they're much more likely to embrace it.
Yeah. Yeah. You can have the best system in the world, but if people don't like using it, it's not going to do much good.
Exactly.
So after all that groundwork, the data infrastructure, the model development, the validation, what were the actual results this company achieved?
The results were really impressive. The most striking outcome was a 50% reduction in unplanned downtime.
Wow, that's huge, cutting unscheduled production stoppages in half.
Yeah, and that has a massive impact on keeping production flowing smoothly, maximizing plant efficiency, and avoiding all those financial losses that come with unexpected shutdowns.
Right. So what about the financial side? Did they actually achieve the cost savings they were hoping for?
They did. They achieved a 25% reduction in their overall maintenance expenses.
That's a significant amount of money.
Yeah.
So where did those savings come from?
It was a combination of factors. Optimizing maintenance schedules, eliminating that unnecessary preventative maintenance on equipment that was running fine,
Mm-hmm.
and of course preventing those really expensive emergency repairs.
Right. And the benefits weren't just limited to cost and downtime, were they?
No, there were longer-term advantages as well.
Okay.
By detecting those early warning signs of wear and tear, the predictive maintenance system actually helped to extend the lifespan of their equipment.
Interesting.
So they didn't have to replace expensive machinery as often,
Right.
which obviously saves money in the long run.
Sure.
Plus, fewer breakdowns means less energy consumption and less waste,
Oh, okay.
which aligns with their sustainability goals.
So it's really a win-win-win.
Yeah, exactly.
Improved efficiency,
Mm.
reduced costs, and a more sustainable operation.
Right.
This case study is a really powerful example of what AI-driven maintenance can do for heavy manufacturing. It's not just about fixing things when they break. It's about anticipating problems and optimizing the entire process.
Absolutely.
So to wrap up this deep dive, what are the key takeaways here? We've seen how this company used IoT sensors, AI, machine learning, real-time data analytics to get a really deep understanding of how their equipment was performing. And the results, that 50% reduction in downtime, the 25% cost savings, those are some really impressive numbers.
Yeah, and I think what's particularly interesting here is that fundamental shift from a reactive to a proactive approach. It's about moving beyond just responding to problems to actually predicting and preventing them.
And this goes beyond just heavy manufacturing, doesn't it?
No, absolutely not.
These principles of using data to predict and prevent problems, they can be applied in all sorts of industries, even if you're not dealing with giant pieces of machinery.
Right. Yeah.
So here's a question for you to think about. How could these principles of data-driven prediction and proactive intervention be applied in your own field or in areas that you're interested in? Even if you're not managing a factory, are there processes or systems where predictive analytics could help you anticipate challenges and get better results?
It's definitely something to consider.
It really is.
Yeah.
What other seemingly unpredictable events or challenges could you manage better by taking this kind of forward-thinking approach? It's a powerful concept.
Yeah, it really is.
It really is.